Hello everyone. This is my MD Jahangir Hussain from MJH Math Assist. Today we are going to solve Mechanic May-June 23 variant 42 question paper. Without further ado, let's get directly into the question. A particle of mass is dropped from a height of 9 meters above the horizontal ground. The speed of the particle at the instant before hitting the ground is 12 meters per second. Find the work done against a resistance. Okay, let's present this information on a rough diagram. This is a particle dropping from a height of 9 meters above the ground. So this will move along this path. Okay, just before hitting the ground, speed is, let's call it V, 12 meters per second, and this initially the ball is 9 meters above the ground. Now you have to find the work done against resistance. You can do it in two different ways. If you consider the resistance to be constant, which is not given here, then you find the resistance, then find work done against resistance equal to resistance into the distance traveled. Although that will not be appropriate. Rather, more appropriate thing will be if you consider work energy principle here. To consider the work energy principle, you see the particle is descending, is losing gravitational potential energy. Initially, the particle starts from rest, so it is gaining kinetic energy, and there is work against resistance. So if you calculate these three things, GPE, gravitational potential energy lost, will be mgh, mass of the particle 1.6, g is 10, so that is 16 into 9, that is 144 joules. That's the GP loss. Then we have K gain. Ke gain in kinetic energy will be initial kinetic energy 0. So final minus initial, half mv square minus half m u square, which will give you half into 1.6 into 12 square minus 0. So that is 0.8 into 144, that is 115.2 joules. 115.2 joules. So we know the dP loss and we know the amount of kinetic energy gain. Then if we apply work energy principle here, so what does work energy principle says there? How it works there? The loss equal to gain plus work against resistance. Loss is 144 joule, that is dP loss. Gain is Ke gain, that is 115.2, and there is work against resistance. So work against resistance will be 144 minus 115.2 joule, that is 28.8 joule. Okay, that's question number 1. Okay, you can also do it in a different way I mentioned earlier. That is, first find the resistance using the Newton's second law. Then resistance into distance will give you the work against resistance. Although whether resistance is constant or not, it is not mentioned here. Okay, now let's move on to the question number 2. Question number 2 is about two particles A and B of mass 3.2 kg and 2.4 kg respectively lie on a smooth horizontal table. A moves towards B with a speed v meter per second and collides with B, which is moving towards A with speed 6 meter per second. So we know the initial velocity of B, but not the initial velocity of A. And in the collision, the particles come to rest. So we know the final velocity of both particles. Now let's present this diagram. this information on a diagram. See, particle A, so let's this particle A, that particle B, particle A, particle B. Let's present the initial velocity above the particle. Particle A moving towards B with velocity v meter per second. Particle B moving towards A with velocity 6 meter per second. It's 6 meter per second after. So this is the velocity before the impact, and after the velocity is after the collision. Let's present it below the particle. So both particles come to rest after the collision. So both particles will have speed 0. Now, if we apply conservative law of momentum, conservative law of momentum here, see, momentum is a vector quantity. You have to consider, that's why you have to consider one of the direction to be positive. Let's say the direction of motion of particle A before the collision to be positive. That case, we have mass of the particle A is 3.2 kg, mass of particle B 2.4 kg. So sum of momentum before collision, that will give you 3.2 into V plus 2.4. That should be negative because it is moving opposite to the positive direction. And after impact, both particles are moving with both particles come, come to rest. So that is 3.2 plus 2.4 into 0. Okay, let's separate this with the from the diagram. Okay, so V will be 4.5 is 4.5 meter per second. So that's the velocity of A before the collision. Now, let's move on to the second part. In the second part, you have to find the loss of kinetic energy of the system due to the collision. So what is happening here? Both particles was moving before the collision. After collision, both of them come to rest. So obviously there is loss in kinetic energy. And both particles is losing kinetic energy. So you have to find the loss of kinetic energy of the system due to the collision. So what do you do? Loss of kinetic energy, kinetic energy, initial kinetic energy of the system minus final, and final kinetic energy is 0. The initial kinetic energy will be kinetic energy of particle A up into its mass into its velocity speed square plus that kinetic energy of A plus initial kinetic energy of B up into its mass into its speed square, that's initial, and final kinetic energy. Both particles come to rest, so final kinetic energy will be 0. And this will be 1.6 into 4.5 square plus 1.2 into 6 square, that is 75.6 joules. That's the loss of the kinetic energy of the system due to the collision. So that's question number 2. Now let's move on to, move to the question number 3. Question number 3 is this one: coplanar forces of magnitude 30 Newton, 15 Newton, 33 Newton, and P Newton act on at a point in the direction shown in the diagram where tan alpha is 4 by 3. See, we don't know the value of tan alpha, but we know the value of tan alpha. The system is in equilibrium. You have to show an expression is in terms of P only. So you see, you have to, there is another unknown apart from P, which is theta. So you have to eliminate theta. Before we go into the sum, you see, we don't know the value of alpha, so we know the value of tan alpha. So you don't attempt to find alpha. Rather, you find the value of sin alpha and cos alpha. Okay, let's consider a right angle triangle in which one of the acute angle is the alpha and tan alpha is given 4 by 3. So opposite is 4, adjacent 3. We find the hypotenuse using the Pythagoras theorem, which will be 5. Now from this one, to find sin alpha. Sin alpha is opposite by hypotenuse, 4 by 5. Cos alpha, adjacent by hypotenuse, which is 3 by 5. Now we know the values of sin alpha and cos alpha. The next thing is, since the particle is in equilibrium, we know the resultant force to be zero. So what you do since the resultant force is zero, so sum of forces along any direction will be zero. To use that, we need to identify two axes first. Let's consider the dotted line to be x-axis, and to find the y-axis, the perpendicular on this dotted line will be the y-axis. So that's the y-axis. Now let's resolve the forces. None of these forces act along the axis. So you have to resolve all the forces. Let's start with 15 Newton. 15 Newton lies in the first quadrant. So both of its components will be positive. Its x component 15 cos alpha. Why 15 cos alpha? Because the angle it makes with the x axis. So x component is cos, and the y component will be 15 sin. Then resolve 33 Newton. Let's resolve 33 Newton. It's in the fourth quadrant, so x component is in the positive direction, y component is the negative direction. An angle with x-axis is alpha, so x component will be 33 cos alpha, y component 33 sin alpha. Then let's resolve 30 Newton. Let's In the second quadrant, x negative, y positive, angle with x-axis, theta. So x component 30 cos theta, y component 30 sin theta. Now to resolve p, in the third quadrant, so x, y both negative, x component p cos theta, y component p sin. Now we have resolved all the forces that are not acting directly on the axis. Now let's take the sum of component along x-axis and y-axis. So along x-axis, since the resultant is zero, so along x-axis, sum of component along positive direction will be sum of component along negative direction. Along positive direction, components are 15 cos alpha plus 33 cos alpha equal to, along negative direction, 30 cos theta plus p cos. So on the left hand side, we have 48 cos alpha. Now the value of cos alpha 3 by 5, and it take cos theta common on the right side. So we have 30 plus p cos theta. So since we will eliminate theta, so make cos theta the subject. Cos theta is 28.8 divided by p plus 30. That's equation 1. Now, if you consider uh, the components along the y-axis, we have sum of component in the positive direction and sum of component in the negative direction. That will give you, along the positive direction, we have 30 sin theta plus 15 sin alpha. 30 sin theta plus 15 sin alpha. In the negative direction, we have p sin theta plus 33 sin alpha. P sin theta plus 33 sin alpha. So, if you keep the theta on the left hand side and take it common, we have sin theta into 30 minus p. The right hand side, we have 18 sin alpha, and sin alpha is 4 by 5. So sin theta it will be equal to 14.4 divided by 30 minus p. That's equation 2. Now to eliminate theta, you know sin square theta plus cos square theta equal to 1. We'll use this idea. Then substitute sin theta in terms of p, which is 14.4 by 30 minus p whole square plus 28.8 divided by 30 plus p whole square equal to 1. That's the expression we have to show. So that's it. That's part A. Now let's move on to part B. What is they are asking? The question is verify that p equal to 6 satisfies this equation and find the value of theta. See, you have to verify. Verify is different from solving, finding the value of p. In case of verification, we simply substitute with the value of p in that given expression. Remember the expression when p equals to 6, what is the value of the left-hand side of this expression? The expression was 14.4 divided by 30 minus p, that's 6, square, plus 28.8 divided by 30 plus 6 whole square. And this one becomes equal to 1, which was the right hand side. So that's verified. So p equal to 6 satisfy this equation. So we simply substitute the value of p here to verify whether p equal to 6 is the solution of this equation or not. Now, once you know that p equal to 6 is the solution of this equation and you need to find the value of theta, so substitute the value of p here to find the value of theta. So cos theta becomes, cos theta is 28.8 divided by 30 plus 6. From this one, we find the value of theta. So that is 36.90. That's the value of theta. Okay. The theta is measured in degrees, so if we keep it correct to 1 decimal place. That's question number 3. Now let's move on to question number 5. Question number 4, my bad. In question number 4, an athlete of mass 84 kg is running along a straight road. Initially, the road is horizontal and he runs at a constant speed of 3 meters per second. Constant speed. The athlete produces a constant power of 60 watts. So, you know the power produced by the athlete. You have to find the resistive force. You see, the athlete is running at constant speed. Whenever a particle is moving at constant speed, working at a constant power, we know at constant speed, acceleration equal to zero, and on a horizontal surface, the forces acting on the particle will be forward driving force provided by the coming from the power, and there is resistance. Since acceleration is zero, so d minus r equal to zero. So the resultant force, which will be zero, and d is power by the constant speed equal to r. So v equal to p by r. Here the power is 60 watt and constant speed is 3. So we are going to find the value of power r equal to P by V. So 60 by 3, that will give you the resistance to be 20 Newton. Okay, that's part A. Then let's move on to part B. The athlete then runs up. The athlete then runs up a section of 150-meter section of the road, which is inclined at 0.8 degrees to the horizontal. The speed of the athlete at the start of this section of the road is 3 meters per second. It now produces a constant driving force. So this time, driving force is constant, and the total resistive force which acts on the athlete along this section of the road has a constant magnitude of 13 Newton. Use an energy method to find the speed of the athlete at the end of the 150-meter section of the road. So let's represent this information on a rough diagram. And if you draw the diagram, things will be very clear. Now, this is horizontal ground. Uh, this is the inclined road, section of the road, whose inclination is 0.8 degrees. And the athlete starts on the bottom of the road. Its speed 3 meters per second. Meter per second, moving with constant driving force. Constant driving force is 24 Newton, and there is constant resistance 13 Newton. And since it is moving along an inclined road, so there will be component of weight against the motion, which is mg sin alpha. That is, mass of the athlete is 84 kg, so 840 mg sin alpha will give you mg sin alpha 840 sin 0.8. You have to use the energy method. Another section of the road is 150 meter. You have to find the speed at the end of 150 meter. What will be the speed here? So, work done by the external force, which is the driving force provided by the athlete. Work against resistance, GP gain, and we don't know whether there will be a gain or loss. If we calculate the segments separately, work done by the driving force, work done by driving force, that will be 24 into 150. That is 3600 joule. Then GP gain, since it is ascending, it will gain GP. GP gain is mg sin alpha into 150. That is 840. Mass is 84 kg. Yes, 840 sin 0.8 into 150. That is 849.8 into 150. That is 1759.2 this joule. And there is work against resistance, which is resistance into distance. Resistance is 13 Newton and the distance is 150. That is 1950 joule. Now, we know the work energy principle. Work energy principle is work done by the driving force plus loss equal to gain plus work against resistance. Now the problem is whether there will be gain in K or not. We don't know. If there is gain in K, then there will be no loss in any form of the energy. So let's say there will be gain in K, then there will be no loss in any form of the energy. Then work done by the driving force is 3600 GP gain, GP gain. If you calculate the sum of GP gain and work against resistance, if it becomes more than the work done by the driving force, then there will be loss in K. So GP gain 1759.234 something plus work against resistance 1950, which is more than 3600 joules. So there will be loss in Ke. So we are sure that there will be loss in Ke. Then if we apply it here, it will be work done. K loss will be initial minus final. Initial Ke half into 84 into 3 square minus final half into 84 into V square. So we have work done by the driving force 3600 and this is half loss in Ke half into 84 into 3 square minus half into 84 into V square. We'll find it out. GP gain 1759.23. Work against resistance 1950. From here we have V. We'll have V. Calculate V. This will be 3600, no, 1759.234 plus 1950 minus 3600. 42 into 9 minus that divided by 42. The root of that will be 2.5 meter per second. That's the speed at the section, at the end of the section of this road. That's part B. One important point to note here. Let's say we do not find out whether there will be gain in K or loss in K. If you cannot figure it out before solving the sum, then let's assume one of them. Let's assume that there will be gain in K. So you will place it on the right hand side. If you consider it gain in K, we'll write the K gain equal to half into 84 into B square. K gain, if you consider it K gain, so what will write? Half into 84 into v square minus half into 84 into initial speed square. So, and we'll place it on the right hand side of the equation, and there will be no loss on the left hand side. And you'll see if you use that one, we'll get the same value of v. Okay, so it doesn't matter whether you can figure it out that there is k loss or k gain. You assume one of them and proceed with the work energy principle, will get the correct answer anyway. So that's the interesting thing about work energy principle. Okay, that's the end of this part. Now let's move on to the next sum, which is question number 5. And in question number 5, we see a particle of mass 0.6 kg is placed on a rough plane, which is inclined at an angle 35 degrees to the horizontal. The particle is kept in equilibrium by a horizontal force of magnitude P Newton acting in a vertical plane containing a line of great slope. See the diagram. The coefficient of friction between the particle and the plane is 0.4. We have to find the least possible value of P. So, see, the particle is kept in equilibrium and you have to find the least possible value of P. This is important thing to figure it out that for the least possible value of the applied force, while a particle is kept in equilibrium on an inclined plane, the situation is there it will be the value of P will be such that it is just sufficient to prevent the sliding down the plane. So whenever we find the least possible value of P of the applied force to keep the particle in equilibrium on an inclined plane, the particle is about to move down the plane. So for least P, particle is about to move down the plane. Okay. So it is about to move down the plane. That is, it is in limiting equilibrium and friction should be up the plane. And in inclined plane, normally we consider along the plane to be the x-axis. So this is our x-axis. Let's consider upward to be positive and perpendicular to this, that is normal to the plane, will be considered as the y-axis. That's the y-axis. Now let's redraw, or we want to show all the forces as outward force. So let's redraw the force P, which will be outward from the particle. And apart from this applied force, there will be weight of the particle, which will act particular downward, which is 6 Newton, because mass is 0.6 kg. So mg 0.6 into 10 will be 6 Newton. There will be normal reaction, which will act along the y-axis, that is normal to the plane. Let's denote it by R. There will be friction since it is about to move down the plane, so friction is the plane. So these are the forces acting on this particle. Now let's resolve the forces which are not acting directly along the axis. These forces are P Newton and 6 Newton. To resolve P Newton, you see it makes an angle of 35 degrees. The result is this component along the x-axis will be P cos 35 and component along the y-axis will be P sin 35. To resolve the weight, the angle between weight and normal, that is y-axis, negative y-axis, is equal to 35 degree. That's the angle the plane makes with the horizontal. If you resolve it, you will see x, y component of weight is 6 cos 35, then the angle with the weight is 35, and x component is 6 sin 35. So we have resolved the Newton force and the weight. Now, since it is in limiting equilibrium, let's equate. If we equate along the axis, along the plane, that is along x-axis, friction plus p cos 35 equal to 6 sin 35. So from this one, F the friction will be equal to 6 sin 35 minus P cos 35. Now, if you resolve normal to the plane, you have normal to the plane is R in the positive direction. The negative direction we have 6 cos 35 plus P sin 35. Now, it is in limiting equilibrium, so you can apply friction with maximum, and maximum friction is equal to mu r. So if you substitute friction and r in terms of P here, you will have 6 sin 35 minus P cos 35. Mu is given as 0.4. R is 6 cos 35 plus P sin 35. From this one, find P. P will be 30 in the denominator cos 35 plus 0.4 into sin 35. The numerator we have 6 sin 35 minus 0.4 6 cos 30, which will be 1.41. That's the value of P. Okay, so that's question number 5. Let's move on to question number next question, which is question number 6. Question number 6. In question number 6 is see a particle P starts at rest. Move in a straight line from point O. So this is very important to identify that this is the boundary condition where start so t equal to 0 at rest, so v is 0, and from a point O, since O is the fixed point, so distance from O initially is 0. So that will be used as boundary condition to find the constant of integration. At time t-second after leaving O, the velocity of P is given by this. Here, B and C, two unknowns are here, where B and C are constant. P has velocity 8 meters per second when t equal to 4, and velocity 13.5 when t equal to 9. The two conditions are given here to find the value of B, and C. And you have to show that B equal to 3, C equal to 5. So let's solve these two equations simultaneously. To find the two equations first, substitute the value of P and V. P4, V8. So 8 equal to V into 4, that's 4B plus 3 into 4 to the power 3 by 2, that's 8. So 8 equal to 4B plus 8C. Divide all of them by 4. So 2 equal to B plus 2C. From this one, we have B equal to 2 minus 2C. Then, second one is B9, B 13.5. So 13.5 equal to 9B, 3 into 9 to the power 3 by 2. So we have 13.5 equal to 9B plus 27C. So that's the second equation. Substitute value of B here. Have 13.5, 9 into 2 minus 2C plus 27C. That will give you C to minus 0.5. Although we can solve the two equations simultaneously from using calculator because they have given here only 1 mark. So what are the necessary conditions here to form two equations? You can write this line only and then this line only. Then solve these two equations directly from calculator and give the value of B and C. So that's how you can do it in the shortest possible time. Then in part B, you have to find the acceleration of t when t equal to 1. To find the acceleration, obviously you need to differentiate velocity with respect to time. So velocity is, if you substitute the value of b and c, we have dt minus 0.5 into t to the power 3 by 2. So if you differentiate it, you have p minus 3 by 2 into half. That's minus 3 by 4, e to the power 3 by 2 minus 1, that's half. Now, when e equals to 1, the acceleration is 3 minus 3 by 4 into 1 to the power half. That will be 2.25, okay, 2.25 meter per second. Yeah, that's the acceleration. That's part B. And what about the next one? The next one, you have to find the positive value of t, positive value of t when t is at instantaneous rest, and find the distance of t from O at this instant. So, first thing, we'll figure out when the particle is at rest. Remember, v is 0 at rest, and the expression for v is 3t minus 0.5 e to the power 3 by 2. To solve this two equation, we take t common from the two. 3 minus 0.5 t to the power 3 by 2 minus 1, that's half, equal to 0. So t equal to 0. And the other one is t equal to 0.5 t to the power half. So from this one, we have t to the power half equal to 6. So t equal to 36. So t0 means the starting time, so t equal to 36 is the answer here. Positive value of t when particle is at rest. Now you have to find the distance of p from O at this instant. To find the distance, you need the expression for distance, which is not given here. So first you need to find the expression for distance, which will be integration of v. So if you integrate v, we have v by 2 t squared minus half t to the power v by 2 plus 1 5 by 2 divided by 5 by 2 plus 6. So s equal to v by 2 t squared minus 1 by 5 t to the power half 5 by 2 plus 6. So here we'll use the initial boundary condition. What does it say? It says that T0 starts from origin. So S0, it will give you C equal to 0. Now, once you know C is 0, then you have to find the value of S when T equal to 36. So let's substitute T equal to 36 in the expression for S. S is 3 by 2 T squared minus 1 by 5 T to the power 5 by 2. 3, 0. So substitute T equal to 36 here. So 3 by 2, 36 square, that's 388.8 meter. That's per feet. That's the exact answer. Okay, now let's move on to the next part. You have to find the speed of P at the instant when it returns to O. It returns to O means in S equal to 0. X, you see the expression for S 3 by 2 t to the t square minus 1 by 5 t to the power 5 by 2 equal to 0. So from this one, you find the value of t square. If you take t square common, you have 3 by 2 minus 1 by 5 t to the power 5 by 2 minus 2, that's t to the power half, 0. So we have t square equal to 0. That's the initial t, or we have p by 2 minus 1 by 5 t to the power half equal to 0. So t to the power half equal to 15 by 2. So t square equal to 225 by 4. Now substitute. You have to find the speed. T equal to, not t square, t equal to this. Now find the value of the speed at this instant. So when t equal to 25 by 4, v will be, remember the expression for v, 3t minus half to the power 3 by 2. So 2 into 225 by 4 minus half to 225 by 4 to the power 3 by 2. That will give you the speed at the instant when the particle is returned to O. That's 42.2 meter per second. It's negative, means we are finding the speed. The speed equal to 42.2, correct to understand this. That's part D. Now let's move on to the next question, which is the last question of this paper. See, this is the sum involving pulley. Two particles, P and Q of mass 2 kg and 0.25 kg respectively are connected by light in extensible string with surface over a fixed smooth pulley. Particle is on an inclined plane at an angle 30 degree to the horizontal. Particle Q hangs below the pulley. Key points A, B, C lie on a line of great slope of the plane with AB 0.8 meter, BC 1.2 meter. Particle P is released from rest at A with the string taut and slides down the plane. So we know particle A, P slides down the plane, starts from A. During the motion from A to C, Q does not reach the pulley. That's important. While P is traveling from A to C, Q does not reach the pulley. The part of the plane from A to B is rough, with coefficient of friction 0.3 between the plane and B. The part of the plane from B to C is smooth. Find the acceleration between A and B, that is while passing through the rough surface. What will be the acceleration? It is, since they are connected by light in extensible strings, the acceleration of both particles will be same. And now, to find the acceleration, first we need to figure out the forces acting on the particle. If you consider Q, Q is moving vertically, since there is no mention of air resistance, we are neglecting it. So the forces on Q are its weight, which is 0.25 into 10, that's 2.5 Newton, and there is tension in the string. And on Q, the forces are, what are the forces? There is tension in the string, there is component of weight to the sine 30. That's 20 sine 30. And there is, since it is moving down the plane while moving through, passing between A and B, there will be friction. So there is friction on A, F, there will be normal reaction, and there is component of weight normal to the plane, which is 20 cos 30. So these are the forces acting on particle P, and it is descending down the plane. So acceleration is downward, Q is ascending. So for Q, acceleration is upward. Now, to find the acceleration between P, acceleration of P between A and B, we are considering the friction. So first, consider P and find the friction. So for P, to find the friction, we will consider to find the normal reaction first. So along the normal direction, R equal to 20 cos 30. Okay, that's 10 root 3 Newton. Then friction is on the friction equal to mu r. Beam is given as 0.3, 0.3 into 10 root 3, that's 3 root 3 Newton. That's the friction, and it is moving down the plane. So if you apply the Newton's second law here F does not represent friction. Let's to differentiate between force and friction, let's denote friction by F. Okay, so along the plane, the forces acting on P are component of weight, tension, and friction. And So it will be component of weight which acts down the plane 20 sine 30 minus T minus friction. 20 sine 30 minus T minus friction equal to MA. So that is 20 sine 30, that's 10 minus T minus friction 3 root 3 mass 2 acceleration unknown. So that's the equation for P. And for Q, if CQ is moving vertically upward, so the resultant force on Q is T minus its weight, T minus 2.5 equal to this mass into acceleration. That's equation 2. So simply add these two equations, you'll have the acceleration 10 minus 2.5, that's 7.5 minus 3 root 3. T cancels out, and that is on the right hand side, we'll have 2.25a. The acceleration will be 1.02393, so correct to CSF 1.02 meter per second square. That's the acceleration between particle, acceleration of particle P when while traveling between A and B. Let's move on to part A2 then. Hence, find the speed of P at T. What will be the speed? You see, to find the speed at T, we know between A and B acceleration is 1.02, and between B and C, friction will not act on P. So the acceleration will be different. So first you need to find the acceleration between while P passes through between B and C. So to find the acceleration between B and C, for P equation modifies to while resultant force along the plane. Okay, let's look at the diagram 20 sine 30 minus P. So 20 sine 30 minus T equal to 2A. That's equation, let's call it equation 3. And for Q, the equation remains the same. And you might be wondering whether T remains same or not. Obviously, since the situation has changed, the tension will be different. There will be special cases when tension will be same, but let's not consider the special case here. Let's consider the tension in this case will be different, and although it will be different, but for both particle tension will be same. So for Q, the equation will be T1 minus its weight 2.5 equal to 0.25A. So that's the question 4. Now add these two to find the acceleration. Let's call this acceleration A1. So 10 minus 2.5 equal to 2.25 A1. So A1 is 10 by 3 meter per second square. Now, see particle P, let's not go back to the original diagram. Let's draw it here. A, that's A, that's B, that's C. Okay. Between A and B, the distance is 0.8 meter. Between B and C, the distance is 1.2 meter. Between A and B, acceleration is 1.02. Between B and C, acceleration is A1, which is 10 by 3. Now we have to find the speed at C. let's call it VC. Then you need to find VB first, and it starts from A, from rest. So for A, you cannot find the speed at C direct. First, you need to find the speed at B. For AB, we apply V square equal to V square plus 2A. So VB square equal to 0 square plus 2 into 1.02 into A, 0.8. So VB will be 2 into acceleration in 0.8. That's 1.2795. Then consider the VC segment. Again, VC square equal to VB square plus 2AS. VB square 1.27995 square plus 2 into 10 by 3 into 1.2. So that will be the speed at C, which is 3.10455, so 3.10 meter per second. That's the speed at the end of when the particle reaches point C. Okay, that's second part. Now to find the third part, the third one, last part is that find the time taken for P to travel from A to C. That's as simple as it is. Again, we find the time to travel from A to B and from B to C. So for A to B, traveling time T1, let's call it T1, V minus U by A. V is 1.02, right? V at the end of 1.27995. 5 minus 0 divided by 1.02, and T2, that's the VC minus VB divided by A. VC is 3.10, VB 1.27995 divided by acceleration by 3. So total time, that's AB, and this will be total time is 1.80. That's the total time particle P takes to travel from A to C. So that's the end of this question. I hope if I understand the whole explanation of this whole question, all the explanation of this question. If you feel it's good, then please don't forget to share with your friends. And please subscribe. If you have not subscribed into my channel, please subscribe. If you did have any other queries, please write your questions in the comment section. I'll try to attend it as soon as possible. So that's it. See you in the next video. Until then, Allah Hafiz. Assalamu alaikum.